Your homework number 9 is due tonight. I'm working on grading exam 2, so I'm going to hold off on making a quiz. There is no quiz this week. And homework 10 is due next Tuesday. I think it's the 23rd. Yep. Okay, so just to introduce this topic, the things we're talking about are radicals. And let's go ahead and put up some of the notation. This n is going to be the root. We'll talk about values of n in just a minute. The sign I just drew, that symbol, is the radical sign. What's under the radical is called the radicand. And for this number, we'll call it x. And then we're going to have an exponent. We'll call the exponent a. So x has power a. Or exponent a. The rational exponent property. So if you have a fraction as your exponent, let x be a real number. Your root little n is an integer greater than 1. So your roots can start at 2. It could be 3, 4, 5, 6, 7, 8, 22, 44, and so on. the property is to take the nth root of x. And write this as x to the power of 1 over n. So n goes in the denominator. So starting at the lowest value of n, which would be 2, the square root of x is also written as just root x. So if there's no value in the root, it's assumed to be 2. But back to this part, this would be your denominator. It would be x with a 1/2 power. The cubed root of x is x to the 1/3. Fourth root of x, x to the 1/4. This time, we're going to have a 5th root of x to the 10th. So take the radicand, x to the 10th. Give it a power of 1/5. And there's a power to a power, you multiply those numbers together. So with 10 times 1/5. We'll have 10 over 5, which reduces to 2. And get x squared. Okay. One way to simplify the thank you for the question. Oh, yes, there is. I think I understand the question. So let me take this part here. And there's a cubed root of x. So one way to look at this is that this value, or any value under here, has a power of 1. Like that. And so you take the power, and that goes in the numerator. That's my 1. And the root always ends up in the denominator. 1/3 power of x. Or there's another way to look at this. And this is kind of what we're going to work on Thursday, but just to explain. You can look at it as a cubed root of x, and you can raise that to a power of 1. It's still the same number if it has power 1. And then your 1 right there, that's your numerator. Oh, this is as your exponent. And then the root always goes in the denominator. So the root's going to go a 3 right there. Yeah. We're going to talk about Well, I can just show you what this result is, but we're going to go through examples for it on Thursday. So if you have x to the m over n. Yeah, but still, I'll just get a little preview of what's coming soon. So x to power m over n n, the denominator, is your root. So it's the nth root. And you can have that numerator as the power under the root or outside. So you can put m right here. Or you can have your nth root x and put the m outside. So you can pick this version or this version. Either way would work. But we're going to practice this on Thursday. Back to my little hint. So I'm going to say if you can get your root and exponent to match, it will simplify your radical. Thanks for the question, by the way. So try to get the root of a root matching an exponent, and that way they'll undo each other. So it may be a better way to say that, but the idea is if you have an nth root of x, and you can write this number with the same power as that root. So you have x with power n. You use exponent rules to get this kind of setup. Then your x to the n, the number, the radicand, has this root n, or a power of 1 over n. And then you multiply these together, n times 1 over n is n over n. Which you get x to the first, which is x. So we're going to start with a 4th root of x to the 12th. Okay, so I'm going to take my problem for my radical. And I'm going to make this x cubed and then with power 4, because I want a power that matches that root 4. Just a reminder, when there's a power to a power, you multiply those numbers together to get when your root and exponent match, they'll undo each other and you'll get this x cubed. Just like over here, you have that power n matching that root n. What's left over is just the value x. In this case, this one right here. Okay, for numbers, you usually want to do a or I would do a factor tree, but basically you want to factor. So 8 is 2 times 4. 4 is 2 times 2. Sorry, I want to simplify the cubed root of 8. Okay, so I was doing that factor tree. So take our cubed root 8 and its factors. Once you've factored this, you're looking at the bottom of the branches where you've got 2 times 2 times 2. So you got a power that matches the root, which means this will simplify to 2. Let's try simplifying. Of a to power 30. So I'm going to go through the work, but just to point out, sort of a shortcut that I started to notice with my other class is if try to see how your root can divide into that exponent. So if we take 30 and divide by 5, what's left is 6. So we're going to have a to the 6th. But just to show you how we're going to get there, a, divide it to the 6th and then to the 5th. To be a to power 30. Let me do that first. A to the 6th, then to the 5th. So that outside exponent matches that root right there. And then what's left is a to the 6th. And again, notice that you can take this 30, divide by the root 5, and get that 6. is 16 to the power of 1/4. Of course, there are multiple ways to solve this problem and get the same answer, but if it were me, I would change the fraction, that exponent that's a fraction, into a root and then work through it the way we've been doing. So I would take this 1/4 power and write it as a 4th root of 16. And then factor 16. 2 times 8, which is 2 times 4, which is 2. About 2 times 2 times 2. 4th root of 2 to the 4th. And this reduces to 2, or simplifies to 2. It's just to, oh, cool question. So question is, why not change the fraction to a decimal and then have that as the power? Let me think about it for a second. Well, I guess a part of my response is I guess is you can. I mean, technically, you could write 16 to a decimal power, like 0.25. But I guess my goal is to teach you about how to use radicals for your homework. And that means like how to change these fractions to roots. So you could do that, but I don't know rules and such, like what to do next. Like let's give it a quick try. Let me do a quick example. Let's say we've got like 9 to the 1/2. And then do some sketch work. And it is, correct to just write down like 9 to a 1/2 is the same as 9 to 0.5. But then they get a little stuck, unless you have a calculator or something. So this is okay, but I'm gonna say kind of stuck. And then try taking 9 to a 1/2. And then after this, there's 2 different things to do. There's the way I've been doing the problem, but we could keep that 1/2 right there on the outside and rewrite 9 as 3 squared. And then you take this 2, multiply it with that 1/2, and get 3 to the 1st, which is 3. So that's one way to get the answer. This way I kind of don't know how to like continue further. And another way is the stuff I've been doing. So you could take the same problem with the power of it. And then change it to a root. To get root 2 of 9. I like to factor these as part of my scratch work. I have a squared root of 3 squared. That's how I could get the same answer of 3. Okay, let me see. Yeah, so it's not, I don't know if we're, so it's not that it's not okay, it's just that the goal for today is to practice using radicals and like being able to do these with like on paper by hand. So that's all. All right, let's do another one. We're going to simplify. Let's see. Okay, we're gonna do 64 with a 1/3 power. So going through how like I would solve the problem, but you know, you could solve the problem in your own way, following the correct exponent rules and such. Get the same answer. So take the 64 with the 1/3 power. Write this as a cubed root. So that denominator is your root. And what's under here is 64. And what I do is start to factor this. I could fully factor 64, but I know that 64 is 4 times 16, and 16 is 4 times 4. I'm wanting 3 of the same factor. Yeah, it's a factor. 3 of the same factor because I have a root 3. So again, you could fully factor down, but I'm going to stop here because I've got 64 as 4 times 4 times 4. And then I've got a power that matches my root. So what's left is 4. Okay, any questions? Any concerns? What we want to talk about next is how square roots are positive values. So if you take a root of something, the answer is positive. Okay, I've mentioned it before, but if there is a blank spot in the root, you just need to know that that's supposed to be 2. So you assume that that number is 2. So square root. It is the non-negative number. So it's a positive number or 0. Extra highlight this because the whole point is that when you take a root, the answer is non-negative. It's 0 or it's positive. Surround this. Is the non-negative number such that okay, so it's a number, so that when you take the square root of x and square it, you get x. Okay, I think I might be missing a little piece here, but let's just start to practice. I think it should maybe say the non-negative number x such that root x squared equals x. Let's just show you what I mean. If you take a square root of 9, the result is positive 3. So you get your root 9, you can write it as a square root of 3 squared, which is positive 3. Not negative 3, positive 3. We have a root of 36. The answer is positive 6. It's a square root of positive 6 squared, which is positive 6. Let's do square root of 0. You could write this as square root 0 squared, which is 0. So that's why we have the non and negative. You can't include 0. And all other square roots are going to simplify to 0 or positive numbers. Square root of 49 is positive 7. Let's do one more. Let's do just 4. Be positive 2. However, there's something a little tricky that starts to happen when we bring negatives in. If there's a negative out in front of the radical, then you're taking a negative of whatever that radical is. So if you've got negative root. Let's do 49. There's that negative sign, and then you can almost think of this root 49 as being in parentheses. So negative of positive 7, just negative 7. Let's do one more like that. So let's look at simplifying negative root 4. So there's a negative out in front of your radical. So I would think of it as even like a negative and then find the root of 4. Simplify that. This negative sign, it was given to you, so just keep copying it down. And inside these parentheses, the root of 4 is going to be positive 2. But your answer, because of that sign that was given to you at the beginning, is going to be negative 2. So the radical is a positive number, but the negative out front makes the whole value negative. Okay, and now we have to bring in negative numbers that have even roots or odd roots. Okay, we're going to start with even roots of negative numbers. An even root of any negative number is not real. It is a number, it's just not a real number. These numbers are called complex numbers, which do come up in some classes, but they're not a focus of our class. So we're not going to go further into the complex numbers, aside from just mentioning that that's what these numbers would be. So I think a pretty straightforward one would be to take the square root of negative 1. So it's an even root, root 2, of a negative number. So the square root of negative 1 is a complex number. It's called pi. So it's an imaginary number. Again, we're not going to go too far into complex numbers, but let's do this. Just go on to the next one. And just say that if you have an even root, like the fourth root of negative, let's do 64. There's an even root and a negative number. So it's not a real number. It's a complex number. All you have to say is not a real number. One more of these. Let's just do a square root of negative 25. Because the root is even, it's a root 2. And the number underneath is negative. So it's not real. Okay, so the next part is an odd root of a negative number is real. It's just going to be the case that we bring the negative out from under the sign into the front. So if we have an odd root of a negative number, and we'll do some examples to show how this happens, but basically what happens, like in a sense, is, you can take the negative out from under the radical. And we're also going to need some results to kind of show how this happens. Maybe a better way to say this, but it will be best to just show you through the example. Okay. So simplify. Backing up. We need some results. I would say that these are properties for radicals, and I'm going to note that it's only for multiplication and division. we're going to let A and B be non-negative numbers. And we're going to use this stuff the way we worded it before. For your roots, they are integers that are greater than 1. So numbers you can count on your finger starting at 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. So okay, so I'm going to separate these with the first property being for multiplication. And we're taking something like the nth root of A times B. It's the nth root of A multiplied with the nth root of B. There's only another rule. That rule is for division. So in the future, in another class, be careful if you have a radical sign and what's underneath has plus or minus symbols, because you want to watch out and carefully simplify something like that. So let's say you have the nth root of A divided by B. We can write this as the nth root of A divided by the nth root of B. Let's simplify. The cubed root of negative 1/8. Root is 3. There's negative and a fraction. Yikes. Okay, just a sec. Need to fix my pen. Okay. Okay, first thing I would do is, since there's an odd root and a negative sign under it, I can bring that negative out from under the root. Oh, I see. Oh no. I've jumped into something a bit more complicated than I wanted to do. We're going to save this problem for later. I'm going to start with something a little more straightforward first. So we're going to start with something smaller. I do want to talk about the negative sign, and we'll stick with the cubed root. Let's have just negative x. Okay, so this is a problem where I'm going to explain why this negative sign ends up in the front. So let's take that negative and write it as -1. And then we're going to use the multiplication rule and have cubed root -1 times the cubed root of x to the 6th. So be sure to use the same root. It's a cube root, not a square root. Multiply with a cube root. So the trick we can use with any of the negative values and an odd root is the negative number to an odd power is still negative. So -1 cubed is -1. And then we have that cubed root outside. And I could have picked any odd number, but I picked 3 because I want that exponent to match with that root. So this is a bit of a trick that I've done. Over here, I'm going to use exponent rules to write x to the power 2 and then to power 3. Because again, I'm trying to get an exponent that matches the root. So here, when these match, what's left is -1. Same thing here, this 3 matches with that 3, and what's left is x squared. Also, just in the future, I would just go with bringing that negative out, like this, just out to the front. And then you can use the trick I've tried to mention is take this power, divide by the root. 6 divided by 3 is 2. Great. Now let's try that other problem. It was also a cubed root and a negative, but it was 1/8 underneath. Rewrite this. So you could do the same thing as over here, is I could write this as -1 and split this apart and take the cubed root of -1, which is -1. In the end, I'm going to have that negative out here, and then I can find the cube root of 1/8. Okay, so don't forget your negative sign as we keep going step to step. So the negative, and then I can write this as cubed root 1 over cubed root 8. Okay, any root of 1 is going to be 1. I can put 1 to whatever power I want to, and it's still 1. So this is a negative. I can put the cubed root, and I can write 1 as 1 cubed if it helps. To see that you could have like the power match the root and what's left is 1. Or if you just want to think about it as 1 with a 1/3 power is still 1. 1 to any power is 1. I like it like this. I like to take the cubed root of 1 cubed, which will be 1. It's over the cubed root of 2 cubed. I can write 8 as 2 cubed. So I end up with -1/2. I think I have a few more examples to try. So let's go. We're going to simplify. Root of this 128. Oh, okay. And then I just thought of another one we'll do after. Note to myself. Okay, so this problem that's kind of tricky. I'll try to remember to do it after this one. So we're going to take this and start to factor 128 and the scrap trick. Okay, so when there's no value here, you need to just assume that it's 2. So it's an even number, which means you can write this as 2 times 64, which is 8 times 8. And if I can get 2 of the same factor, then I can write that as that number with the power that matches that root. So I'm going to stop here and write 8 squared times 2 is 128. Okay. I'm going to go ahead and start to split this up a little bit. So what I've got is a root of 2 multiplied with a root of 8 squared. And then times that root x to the 5th. So 2 is as factored as it can be, and its power of 1 is less than your root of 2. So this, when the power is less than the root, you can't simplify this any further. So this stays here as root 2. 8 squared, that power 2 matches the root 2, so what's left is 8. And with x to the 5th. I need, or I would like to have the root match the power, but it's an even root. So we'll need to take one of these values of x off. Or how else could I explain this? I think that's how I would go, x times x to the 4th. So number right now is 8 root 2. It's easier to read that way. And we're going to break this into root x times, I think I've made this a bit messy. There's probably a better way to work through this, but I'm going to keep on going. There's a root x and then the root x to the 4th. This power is 1 and the root is 2, which means this root of x cannot be simplified any further. But this power of 4 is greater than the root of 2, so I can simplify the root x to the 4th, which would be x squared. So I've got this 8 root 2 root x times x squared. And again, there's probably a faster way or a better way to explain solving this. I would put this back together. The root of 2 times the root of x is the root of 2 times x. And if I were putting this in as like a solution on homework, it's easier. I guess answers are usually written like 8 and then the x squared and then the root at the end. 8x squared root 2x. Okay, so let's say that someone gives you a problem and it looks like square root of a squared plus b squared. There were only 2 rules, one for multiplying and one for dividing. There is no rule for adding. So unless it's some kind of thing that you can factor somehow. Like example if you have time. But in general, it's not. It cannot be simplified further. It's not going to be a plus b. Let me make another example. I'm going to do something like this. Never mind. Let's just use things. Let's use our time in class to work on problems that we can simplify. Square root 72. So I would start to factor that 72. It's even, so it's 2 times something. Actually, I wrote it as 8 times 9. And then factor 8. Okay, so this is how I used to explain it, like as a tutor. So you have a square root. So if you can find pairs of factors, that number can come out from under the root. And maybe next time I'll try to remember, like if you have a cubed root, then you want 3 of the same factor. If it's a 4th root, you want 4 of the same factor. And then that factor comes out from under the root. So with your square root, I can bring out pairs. Like this pair of 2s gives me a 2. And this pair of 3s gives me a 3. It's 2 times 3. And then this 2 right here is left over. It stays under the root. So I got 6 root 2. See if we can do another one like this. Okay, this time we'll do 72, but find it a cubed root of 72. So we're just going to factor it the same way. 8 times 9. 9 is 3 times 3. 8 is 2 times 4, which is 2 times 2. So if I were in the math lab helping someone with this problem, I would say, you've got a cubed root, so you want 3 of the same factor, and then that number comes out of the root, the cubed root. So since I have 3 2s, or maybe we'll circle like 3 times. There's 1, 2, 3 of these, so I can bring out the factor 2. But I don't have 3 3s, there's only 2 of them, so they have to stay underneath the cubed root. And then, so that 9 stays under here. 3 times 3. I think we're out of time. Pretty much out of time. So we're going to call it good for now. But I have a few more results to go over on Thursday. And then maybe we can do more practice and examples after that.